Assalamualaikum, I'm Sanjita Akhtaripar. Today I will explain how we can build and deploy the front-end layer of a web application using Amazon Web Services. This setup ensures high performance and auto-scaling. Let's start with Route 53 DNS. It's basically a domain name service system that routes users to the nearest or fastest servers, improving speed also. The next one is the Elastic Load Balancer, evenly distributes incoming traffic among servers to prevent overload. It also handles secure HTTPS connections and works with auto scaling to adjust automatically as demand changes. One is EC2 instance. Our frontend runs on EC2 instance in an auto-scaling group. These servers are stateless, so they can be added or removed easily, keeping the systems efficient and cost-effective. The next one is S3 and CloudFront. For static files like images, CSS, and JavaScript, we use Amazon S3 and CloudFront. S3 stores the files securely, while CloudFront delivers them from the nearest location for faster load times.
Now, if we look at the diagram on the right, a user first makes a DNS lookup through Route 53. Their request then goes to CloudFront, which serves cached or static files directly from S3. For dynamic content, CloudFront routes the request to the Elastic Load Balancer, which distributes it across multiple EC2 web servers. These servers communicate with the backend layer or private S3 buckets when needed. Finally, CloudWatch monitors system performance, and autoscaling ensures the infrastructure adjusts automatically to keep everything healthy and responsive. To sum up, this front-end architecture powered by Route 53, ELB, EC2, S3, and CloudFront delivers a fast, secure, and scalable experience for users around the world. It ensures continuous performance with minimal downtime, while AWS automation handles scaling and monitoring seamlessly. Thank you.
Our second deployment scenario is private data center hosting, where we use our own hardware servers instead of cloud service. This setup gives more control, better performance, and very low latency between servers. However, it requires manual management. We don't get auto scaling like in the cloud, so we must plan capacity carefully before traffic increases. Here, a hardware load balancer is used to handle request and distribute traffic. For storing files, we can use different systems such as FTP server, storage area network, or even NoSQL data stores depending on our needs. Private data centers are also useful for companies that must follow strict security or legal rules, like keeping all data within a certain location. Overall, while cloud hosting is cheaper and faster to start with, private data centers become cost effective and reliable as infrastructure grows, offering maximum control, performance, and security.
Private data center hosting is a deployment model where web applications run on dedicated physical servers instead of cloud infrastructure. In this setup, only a few services like DNS and CDN can be easily outsourced. Using bare metal servers provides major benefits such as predictable latency, high throughput, and sub-millisecond communication between servers. However, it also demands manual management. There's no auto scaling, so capacity must be planned carefully in advance. A hardware load balancer like HAProxy or Nginx handles incoming requests and can include caching or reverse proxy layers to improve performance. For file storage, options range from FTP servers to storage area networks or NoSQL data stores depending on data size. Files must be served through a CDN by adding a web server layer in front of storage. Although cloud hosting is cheaper and faster to start with, private data centers become cost effective and powerful as systems grow large. They offer better performance, lower hardware costs at scale, and are essential for organizations with strict security or legal requirements, such as those requiring data to remain in specific locations.